If we want to draw Lewis structures of polyatomic ions, we need to pay attention to the charge and how that plays a role in calculating the number of shared pairs. In computing the number of shared pairs for a polyatomic ion, we still use the relationship Sp equals 1/2 Er minus Ve. The only difference between molecules and polyatomic ions is in the number of valence electrons. For example, in the ammonium ion, the 1+ charge indicates one electron has been removed. The formula is not specific as to which atom has lost the electron, but somewhere one valence electron has been lost. In the computation of Sp, we need to subtract 1 from Ve. Since nitrogen wants 8 electrons and each hydrogen wants 2, Er for this ion would be 8 plus 4 times 2, or 16 electrons. Nitrogen is in group 5a and hydrogen is in group 1a, so together they would provide 9 electrons. However, we need to subtract one of these to account for the 1+ charge of the ion. So Ve equals 8. Using the formula for shared pairs, we find that there is a deficit of 8 electrons, or 4 shared pairs of electrons. In the sulfate ion, the 2- charge indicates that 2 electrons have been added. Again, the formula is not specific as to which atom or atoms have gained electrons, but somewhere 2 valence electrons have been gained. In the computation of Sp, we need to add 2 to Ve. For Er, there are 5 atoms, all wanting 8 electrons, so Er is 5 times 8, or 40. Sulfur and oxygen are both in group 6a, so neutral atoms would provide 5 times 6, or 30 electrons. However, we need to add 2 more electrons to account for the 2- charge of the ion, so Ve equals 32. Using the formula for shared pairs, we find there is a deficit of 8 electrons, or 4 shared pairs of electrons.